we're asked to determine a parameterization for the curve shown below. Notice how I have an ellipse that's traced out counterclockwise. The equation of the ellipse is x squared divided by 4 plus y squared divided by 16 equals 1. To write our parameterization of this curve, we're going to use the identity cosine squared theta plus sine squared theta equals 1. Notice how both these equations are equal to 1, and therefore to write the parameterization, we can let x squared divided by 4 be equal to cosine squared t, and y squared divided by 16 be equal to sine squared t. So if we let x squared divided by 4 be equal to cosine squared t, if we multiply both sides by 4, we'd have x squared equals 4 cosine squared t. And now taking the square root of both sides of the equation, then we'll take the principal square root, and therefore we would have x, or if we want x of t, equals 2 cosine t. And now we can let y squared divided by 16 be equal to sine squared t. So multiplying both sides by 16, we'd have y squared equals 16 sine squared t. And now again, taking the principal square root of both sides of the equation, we'd have y, or y of t, equals 4 sine t. So again, we have x of t equals 2 cosine t, and y of t equals 4 sine t. To trace out the entire ellipse, t would have to be on the closed interval from 0 to 2 pi. But we still need to check the orientation. For example, at t equals, let's say, 0, x of 0 would be equal to 2 times cosine 0, which would be 2 times 1, which equals 2. And y of 0 would be equal to 4 times sine 0, which is 4 times 0, or 0. So at t equals 0 at this point here, let's go ahead and check the values of x and y at pi over 2. So x of pi over 2 would be equal to 2 times cosine pi over 2, which would be 2 times 0, which is 0. And y of pi over 2 is equal to 4 times sine pi over 2, which would be 4 times 1, which equals 4, which would be at this point here, giving us the correct orientation. So here's a possible parameterization for the curve with the given orientation. But let's also write this as a vector valued function. We could say the vector valued function r of t would have an x component of 2 cosine t and a y component of 4 sine t, again where t would be on the closed interval from 0 to 2 pi. I hope you found this helpful.